This is Dan Abbott. I am making this video as an aid for the Comp 115 Technical Graphics for Composites class at Southern Maine Community College. This is to help you with the WindBlade exercise that we're doing. The intent here is for each of you to design a WindBlade with a different cross-section and possibly different twist and other characteristics. The basic dimensions I want you to use are indicated in this AutoCAD drawing. And the reason for the limitation, and this is inches now, the reason for this limitation is we're planning on vacuum forming these blades, and our equipment is going to allow us a maximum blade length of 18 inches. So being a little conservative with 16 inches total length from the bottom of the end of the hub out to the tip of the blade itself. The widest point, the chord on the cross section, is going to be 3 inches, and we'll have it taper down to 0.8 inches overall. What we're after, and here's an example of one in SolidWorks, we're after a shape that looks something like this. And if you notice, the front view is looking at the small end, looking down the blade. And the reason for that is I would like to print some of these. In fact, you may hear some sound in the background right now, and there's a 3D printer with the stepper motors making that sound, printing this particular blade in 2 pieces. In order for that to work as well as possible, what you want to do is start with the front view being the cross section. So what I want to do is to show you some techniques for locating a cross section, a variety of cross sections, and bring them into SolidWorks either as a curve through points or bringing in an image and then tracing that image in SolidWorks. So we'll start by going to a website called airfoildb.com, and airfoil is the reference to airfoils. Mostly these are airplane-based airfoils, but the basic shape or the basic cross-section is used in horizontal windmills quite frequently. So we're going to look there for a basic shape, and the DB is just database. This website was really set up for hobbyists who are doing radio-controlled airplanes. But if you get out of the browse and search area, this website, it has a large number of airfoils, and if you just kind of drag over, you'll get a sense of what the different shapes are. So what I want you to do is to go through, and this is just starting with the A's, AH's in fact, and there's just thousands of these things in here. So I want you to look through and find something unusual, find something interesting that we can try as an experiment. So I'm just going to grab 79-100C airfoil, looks pretty good to me. So I'm going to grab that, and what happens when you pick it is it gives you an image, and it also gives you a means of downloading this image in a format that can be brought into another program. And the DAT format is text-based indication of the X, Y, and Z locations. And by the way, all of these have a unit length from the tip of the airfoil to the tail of 1 unit. So depending on how you bring it into SolidWorks, that will either be 1 inch or 1 millimeters. So we're going to go through first and change that so that it comes in at the 3 inches that we want. One technique is just to do a screen capture and then to bring the image itself into SolidWorks and trace it. The other, though, is to go to the DAT file. If we were to open that file and take a look at it, it's a series of X and Y coordinates starting with 1, 0. It also has the name of the particular airfoil right here. In order for us to use this in SolidWorks, we need a couple of things. One, we need a third column that has zeros in it, and we need to get rid of that header material. So what I'll do, so go back to the original page, and instead of selecting DAT and opening it up, we're going to right click, and then we're going to do a save linked content as. It gives us an opportunity to save this file. It's going to be saved with the DAT extension. I'm going to change that to a TXT extension, and I'll put it in the downloads file, and just so I can keep track of it with something more descriptive, I'll call it AH79-100, which is the number that it was given to it, and then save it. Now I need to modify it a little bit, so I'm going to do that by going into an Excel spreadsheet. Here's our spreadsheet right here, and I'm going to go and open up that file. To do that, I need to change the file type from the Excel files to a text file type. Now when we go down looking for the AH in our downloads folder, which is where I put it, it's right here. I'm going to go ahead and open it up. Now as I'm opening it up, I'm going to have some decisions to make. One of them is whether to bring it in delimited, which I want to do. That simply means you want to put it into columns based on a delimiter of some kind. I go to next, and now I get to pick the kind of delimiter, and since this is comma delimited, I'm going to change it from tab to comma, and it shows me down here that it'll come in 2 columns. I go to next, I now finish it, and I've got 2 separate Excel spreadsheet columns here. And the first thing I'm going to do is to right click and delete that row that has the information in it about the header material. So now we're starting with 1, which is the overall chord length, and 0, and then after that it's a series of XY coordinates. SolidWorks is going to expect a Z coordinate as well, so we'll just go ahead and put a 0 here. After that 0 is in there, I'll just right click and copy it, drag down through to the end of this column, and add a 0 of the Z-axis 0, so we'll have a flat pattern when we bring it into SolidWorks. Just cover everything, right click, and then do a paste. Once you've done that, there'll be zeros in all these locations. Now I really want all of these values increased by a factor of 3 so that I can have a chord length of 3 and then end up with the overall shape. The 3 meaning that 3 inches right here on the maximum length. An overall shape that's 16 inches long and then the 3 inches wide. I can do that here with a formula, or I can do that when I bring it into SolidWorks by just scaling it up. What I'm going to do is to save this file, and I'm going to save it on my computer as a CSV, comma delimited file. And I need that because it has to be comma delimited. So I'll go to my downloads file, and I will call this AH 79-100. Some features might be lost. I'm going to do it anyway. Now I'm just going to close out this Excel spreadsheet file. Say don't bother to save it. I've already got it. I'll close this one out as well so we don't have the spreadsheet open it at all. What I'm going to do is to change the extension on this CSV file, and I'm doing this because SolidWorks won't recognize it if it doesn't have a TXT extension. Now this is one we're going to use. Now if I open that file up as a text file, you'll see that it consists of columns separated by commas, which is what I need for SolidWorks. Now I'm going to go back to SolidWorks. I'm going to start a brand new file. It's going to be a part file, and I'm just going to make sure that it's in inches, so when those curves come in, those points come in, they're going to be measured in inches. Now I'm going to go to Features, and what I'm needing to do at this point is go to the Curves menu. And under the Curves menu, there are 2 types of curves, a helix and spiral, or a curve through X, Y, Z points. And this is the whole point of going through that Excel spreadsheet, downloading the DAT file, etc. If I go and browse for that file, I'm going to look for it. It's looking for an SLD CRV file, which is not the file extension that I placed on there. I made it a text file. So we'll go up to Downloads, which is where I had it stored. That's the file that I just created. I bring it in, pick OK, and it literally sketches out that shape that you just saw. Now it does that on the front plane. You can see that looks very much like the shape that we have right here. So go back to SolidWorks, and what I'm going to do now is to use that curve that was brought in, and I'll use that curve by converting it into a sketch. So I'll go to the sketch function, pick the sketch button, say let's sketch on the front plane, convert entities, select that curve that was brought in, pick the check button, and now what you can see is I have a closed shape fully defined that is based on those curves that came in. And at this point I can use that as a way of creating a loft, and that loft will then be our airfoil. The other technique that you could use for this, I'm going to pick OK here, and I'll start a new file. Another part file, also in inches. So the other thing that I could do is to go over and actually get an image of some kind. Now there are a number of ways to get images, of course. In this particular case, what I'm going to do is just to make it larger so it looks like that, so I can get a pretty good look at it on the screen. And then what I'm going to do is a print screen. Actually, I happen to have Snagit, so what I'll do is print it using Snagit, which allows me to crop it as I'm copying it. You could do a print screen and bring it into a piece of software and crop it there if you wanted to. In fact, let's do this just as an image file. So instead of copying it to the clipboard, I'm just going to copy this and then go to the Snagit file. And under here, then it asks me what I want to do with it. I'm going to do a save as, and I'll create a JPEG file out of this one. And I'll put that, since I've been using my downloads folder to put everything else, I think that's where I'll put this as well. So my downloads folder, which is here and here. Okay, now I'm going to change the name of this and I'll give it the same name I gave the other files, AH79-100. It's a JPEG file. We'll save that. Now I don't need this anymore. I'll just close that out and I'll minimize this and minimize this. So now I'm back in SolidWorks. In order to use that, what I need to do is to start a sketch. This time I'll start a sketch on the front plane, and then before I actually start sketching anything, what I'm going to do is go to the Tools pull down, and under the Tools pull down there's something down here called Sketch Tools, and under Sketch Tools there's a tool called Sketch Picture, which is off the screen the way it's set up right here. Let me see if I can get it to show up. Okay, Tools, Sketch Tools. Well, down at the bottom, it's just off the screen here a little bit. I'm going to move my, no, I guess I can't get it down without changing the way I've got my set up. Well, I'll tell you that if you, right now you're looking, it says close sketch to models, check sketch for feature. If you go down a couple more, there's an option called Sketch Picture, which is what I'm selecting right now. When you do the sketch picture, it's asking you to go and find the sketch you want to use. The one I want to use is right here. So I'm going to open it up and it just drops it right into my sketch and it looks like that. Now this one, because I just did a screen capture, it has no idea how long this is. So I'm going to start now by just picking this, bring this in. I'm going to draw a center line, goes to my origin. I'll bring it out, put a dimension on it because I want this overall to be 3 inches. So I'm just going to give it that a dimension of 3. And then I'm going to go and grab my image. And when I grab the image and double click on it, it allows me to reduce the size and to move it. So I'll move it so that the point is right about here. And then I'll scale it down so it's about the right length. And this is an approximation, I have to say. This is all done by eye. But you can still come pretty close by just going back and forth a little bit, deciding right about there how close you need to get, and I think that's good enough. So now that I've got this, what I would do is go and I just sketch on top of that shape, and that sketch is going to be something I'm going to do with a spline. The spline command is right here. When sketching with SolidWorks and sketching on top of an existing image, it's sort of nice to have a target. So since this is 3, let's just say I want to go every, I don't know, quarter inch or so. So let's take and create 13 divisions here by drawing another center line. We'll draw that center line through the origin so it's nailed down to the origin, and then I'm going to use a linear sketch pattern. The x-axis in this case requires that I have another sketch. So I'm going to draw another line that comes out through. Oh, I've already got a line there, don't I? Oh, yes, I do. Sorry. So I'm going to go back and do a linear sketch pattern. And when it asks me for the x-axis, I'm going to select that line that I've already drawn. And I will make the distance between 1/4 of an inch, and we'll put 13 of them in there. And pick OK. And now what it did is I'm going to back up here. And the reason I'm backing up is because I wanted to pick the line that I drew as my direction, but I didn't want that to be the line that was actually being arrayed. So go back. My x-axis is going to be that line right there. Now, the object that I want to array, which I need to select down here, is going to be this line, the one going up like that. I want 1/4 of an inch space, so 0.25, and I want 13 objects, so I'm going to go to 13. So now you'll notice that I've got these 13 lines going through here. And the only reason I put those there is just to have a sort of logical target for placing points. I actually probably want more points here because of the way that turns around. So let me go back and do another linear sketch pattern. And now instead of a quarter, let's just go with 0.05, and we'll put a number of those in here. 0.05, not offset but linear. Also the x-axis, and we still want as our entities to pattern to be that line right there. We'll go up 0.05 and 0.05 for, oh, let's just say we want 10 of those. And that just gives us a little more control as we come through the area that's going to change pretty dramatically. So now we'll go back over here. I'll do a spline. I'll start the spline out at the end here, and I'm just going to go and just select a point on each of these lines that is as close as possible to going through my sketched image. If I come here, here, I guess you don't really need to see me do the whole thing, but I do want to get to the point about there. So what I'm trying to do is to stay as much as possible in the center of this, and because this starts to change a little more dramatically, I'll go along until I have to make a change. So now I've got a spot here, 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 and this is really where this dramatic change is most noticeable. So you can see what it did is it wrapped around the nose a little more like the actual sketch itself. So you just go through and finish this up. I'm going to pause this one. So now I'm at the end. When I'm done, I just press the Enter key, and now I've got a sketch that I can use. I'll come back out of here, and you can see that sketch. A lot of things going on in it, but you can see the basic sketch itself with all those lines. Those lines can be hidden if you don't care to see them. So my sketch looks like this. It's a sketch on the front view. So what I'm doing now is I'm going to go and make a few planes and then change overall the length of that. Now what I need to do is to create a plane that I can draw the small end of the wind blade on. And if you've been paying attention, you might notice that I've actually switched overall shapes. I've opened up a file that I've already used to create a wind turbine, so I can maybe make this video a little bit quicker. So the first thing I need to decide is this: do I want this blade to turn counterclockwise or clockwise? If I want it to turn counterclockwise, what I want to do is to add the small end out here, coming toward the screen. If I wanted to turn clockwise, I need to add the small end on the other end. So let's go with clockwise on this one, since that's what most wind blades do seem to be doing. So we're going to go over to Features, Reference Geometry, and under Reference Geometry I'm going to say I'm going to add another plane. Since we started by drawing on the front plane, I'll select the front plane as one of my references, and then I'll type in 12.5. 12.5 is the length I want this blade to be. It's coming out instead of going in, so I'm going to go to the left and pick Flip. Now that plane gives me a place to draw the small portion of the wind blade on. I'll go over to the Sketch function, pick the Sketch button, and I'm already on that plane. So now I'm going to look at this. Let's look at it instead of from the front. Let's look at that from the back so that the small piece is closer to us as we're viewing it. First thing I need to do is to convert the entities themselves, and then I'm going to scale them down. If we look at our original wind blade shape, the small end 0.8, the largest end, which is what we're creating right, what we already created right there, is 3. So if I want to figure out how far to scale that, I'll take 0.8 divide by 3 to determine what the ratio would be, 0.26. So if we make it 27%, it'll give us the 0.8. So go back to SolidWorks. First thing we need to do is to do a convert entities. I'll select that sketch. Shows up over here. I pick the green check and it converts the entities, shows them there. Now I'm going to go to the Move Entities drop down, little arrow beside it, pick Scale Entities, put a window around all of those sketch entities, pick Scale About over in the Properties Manager. I'm going to select the origin since that's where I placed this initially. And because I've already done this once, 0.27 comes up as the default. That's the value that I got when I divided 0.8 by 3. I'll pick OK. Looks like that. Now, most wind blades have a twist to them. There are two ways to place the twist. One is to do it here, and one is to do it with a twist option of the flex feature. Instead, I'm going to do it right here, and because I want this to go clockwise, the appropriate way to tilt this is to tilt this end right here down. I'm going to go about 10 degrees, anywhere from 5 to 20 is considered okay. So we're going to twist this 10 degrees for right now. So I'll go back up to the Move Entities drop down. This time I'm going to pick Rotate Entities, put my window around all of them. Center of rotation will also be the origin. We'll go over and type in a 10 for 10 degrees, and that's the opposite direction that I want to go, so I'll go and put a negative in here. So again, this is when we want a clockwise rotating wind blade, looking at it from the small end down to the wide end with the larger part of the profile to the right. Now that I've got that, we'll come back out. I've got my two sketches. I'll go over to the features, indicate that I want to do a lofted boss or base. I'll pick one of the sketches near the top, the other sketch near the top, and it comes in like that. And if we now, I'm just going to hide that sketch and that plane. So now if we look at it straight down from one end, you'll see we have a shape where this end twists down a little bit, so that whole twist comes down through the blade like that. And there's our basic, our fundamental part of the blade. So now what I'll do is add the base, the circular base that we're going to use to attach the wind blade to the hub. To do that, I'm going to add a plane away from this surface, 2.5 inches away. Actually, I already put that in, so we'll come over here and look at it there. That's just a reference plane. And then I'm going to sketch on that reference plane. What I plan to sketch in that reference plane is that circle right there. So looking at it from the front, what I did was sketched a construction line that went from the origin to the tail. And then I placed a circle on that construction line, and I made sure that the circle itself went right through the origin by adding a relationship. Gave it a diameter of 1.5 since I want a 1.5 inch hub at the end. And now that it's in place, what I want to do is to make a loft that goes from this surface to this surface right here. I need another sketch of that shape. So I'll go into the sketch function. So let's sketch on that surface right there. Do a convert entities of that entire face. Now I have another sketch, and you can see it over here. It's just sitting, sketch 11 it's called. Sketch 3 is the circle, sketch 11. So if I do a loft from sketch 3 to sketch 11, I'll have that shape. I won't really care for it though, and I'll show you why. If I come over here to the lofted base, I say do a loft from here to the circle. It goes straight down like that, and what I want is a little more control. I don't want that to curve in. I want that to kind of sweep down in a reverse OG so that it looks a little better. Nothing particularly wrong with that, but I just don't happen to like it. So we'll get out of the loft itself. I'll go back, and now what I need is to add a couple of guide curves. So I'll do that from the top view. Looking down at it from the top, I'm going to go back and sketch on the top plane. When I sketch on the top plane, I'm going to start by just sketching a line that goes from the origin right down to my circular sketch. Now what I want to make sure is that the end point right there, which you see right now can go almost anywhere, I want that to have a pierce relationship with that circle to make sure that it goes through that circle. So I'm done with that sketch. Now I want to put another sketch, and this new one is going to be also on the top plane. Okay, so I've got my profile, another profile, and then a guide curve. So go back into sketches, go back to the top plane, looking at it directly from the top. I'm going to sketch a spline that goes kind of in like that, over like this, down like this. I don't really want it to go quite all the way, but it's more or less the shape that I want. So now I'm going to take the end point of that spline, holding the control key down. I'm now going to select the circle, and once again I'm going to create a pierce relationship so it pierces the circle on the same plane. Do the same thing at this end. Take that and the other sketch that I created, have a pierce relationship. We've already got a coincident relationship there, so let's go back and do that again. Okay, there is our pierce relationship is already set. So now it's pierced, yeah, that point is on that surface right there. So now if I look down at it from the top, I'm going to go and do a little graphic problem here. I'm just going to adjust that so that it comes down a little more smoothly. So I'll have it kind of continue on for a little while, come down, transition into this. I like the look of it, kind of a reverse OG. Pick OK. So I've got 4 sketches that are going to be involved with this next loft. And those 4 sketches will allow me to do a lofted base, pick a profile, go down to guide curves, pick that guide curve, which you see kind of makes the whole thing go off squirrely. So I'm going to add the straight guide curve as well. So now one edge is going to be straight, the other one's going to go down in reverse OG. That's my basic shape right there. Now if I go over and extend this by sketching on that surface, doing another convert entities of that surface, sketching on that surface, convert entities of that surface. Now that circle is going to be the same size as the one that it was originally created with. We'll go over here and do an extruded boss or base. I'll go out 1.5 inches. 1.5 inches gives me what I want, and that's my entire wind blade. Now what I'm going to do is to split it so that I can print it, because the printer I'm going to print it on will not print the entire length of that wind blade, which at this point should be about 16.5 inches. So let's go and just check that. I'm going to measure it from that surface to this surface here, 16.5 inches. That is well within our 18-inch limit. I don't want to get too close to that 18-inch limit, so we're going to be well within our 18-inch limit. So we have a 16.5-inch wind blade. Because my printer won't go up above 9 inches, I would then put a plane in the middle and then add what's called a split relationship and to split it in two. That's enough for this one.